Good morning. Today we'll talk about the law of sines. The law of sines is another law on your Regents reference sheet or formula sheet, so it's nothing you need to memorize. Today we're just going to talk about working through it and doing some word problems with it. So you should start in your Inspire document, number 11, called the law of sines. You should also have your Regents reference sheet and your lab packet handy. Here we go. So in your on your Inspire document, the law of sines, if you go to page 1-2, this is very basic. There I show you the law of sines. The law of sines states that these proportions are true. So we have side A over the sine of angle A equals side B over the sine of angle B, which is equal to side C over the sine of angle C. Now, you'll never use all three pieces. You pick the two that are most convenient to you. And again, just like with the law of cosines, we might not have a triangle named ABC. It might be LMN or PQR or something like that. So be able to substitute appropriately. And really, most people see the law of sines as easier, and that's nice. That's why I start with the law of cosines, so that as we move along from here, we've started with the most difficult thing and everything else seems simpler. You can't always use the law of sines. Notice with the law of sines we have more angle information and less side information, and those are the decisions we'll have to make at the end of the unit when we have to decide which formula to use. But today it's always going to be the law of sines. So if you look at your Regents reference sheet, let's just find your this law on the Regents reference sheet. So yesterday we talked about the law of cosines, which is right there. Notice down here there is your law of sines. Okay, so again, it's another law that you do not need to memorize. It is on the reference sheet for you. We just need to learn how to use it. That's our goal today. So on your lab packet, day 12, we have the law of sines. So let's rewrite it again. The law of sines just says that a side of a triangle is in the ratio of the sine of the angle opposite it. That ratio is equal to the same ratio for all the other sides. So B over the sine of angle B, side C over the sine of angle C. And again, we'll only ever use two parts at a time, just depending on the information we know. They're just trying to tell you that all the sides are in proportion with their angles, the sine of their angles. So here we go. First problem. In triangle ABC, side C is 12, angle C is 45, and angle B is 120. Find the exact value. That, as it's been right along, is a hint for no calculator. Must be a unit circle thing of side B. So for this problem we're given side C and angle C. Angle B, we're looking for side B. So we're going to use those two pieces of my law of sines. So I'll rewrite it. B over the sine of angle B equals C over the sine of angle C. And substitute. I'm looking for side B, I'll leave that alone, over the sine of angle B, over sine, B is 120. That's equal to, the length of side C is 12, over the sine of angle C, sine of 45. And again, immediately you should be saying to yourself, oh yeah, I know those values for my unit circle. That's why it said exact value. Now, anytime we have equal fractions, we can cross multiply. It's a good old friend. So I'm going to cross multiply this way, and I show the steps because someday we'll need to use our calculator and you want to make sure you can do it all in one step. So when I cross multiply this way, I get B times the sine of 45. That's equal to, when I cross multiply this way, 12 times the sine of 120. Okay. Let's replace with what we know. Sine of 45 is root 2 over 2. That's equal to 12 times the sine of 120. 120 is a child of 60. Go back to your unit circle. Here's 60. Here's 120. It's in quadrant 2. Sine is positive in quadrant 2, and the sine of 60 is the square root of 3 over 2. So the sine of 120 is positive square root 3 over 2. So I need to get b alone. Well, I've got fractions, so I'm going to multiply, because the opposite of division also is multiplication. So I'm going to multiply by 2. What I do to this side, I'm going to do to this side. And that's nice, it cleans those 2's up. So now I have the square root of 2 times b equals 12 times the square root of 3. I need to get b alone, so I divide by the square root of 2. Those cancel, and I have b equals 12 square root 3 over square root of 2. Well, that's no good for New York State. I need to clean up the square root in the bottom of the fraction. Multiply both parts by that square root of 2. So up top I have 12 times the square root of 3 times the square root of 2 is the square root of 6, all over square root of 2 times the square root of 2 is 2. And then finally you can reduce. 2 goes into 12 6 times, and you're left with 6 square root of 6. And that's it. Just learning how to plug in to a new formula and get answers out. Now, let's review how to use your calculator in case this was a calculator problem. So go to your Inspire, grab a scratch pad, and I'm going to enter 12 times the sine of 120 divided by the sine of 45. Because if you go back to your notes for a minute, if I didn't know these exact values and I needed to use my calculator, to get b alone, I would divide by sine 45. So b is equal to 12 times the sine of 120 over the sine of 45. Again, this is just to remind you of how to use your calculator when you're allowed to. Exact value means no calculator. I'm just trying to show you everything in one problem. So going back to your Inspire again, scratch pad, I'm going to have a fraction and type 12 times the sine of 120, that's 120 degrees. Again, I hover, make sure I'm in degrees mode, I am, over sine 45. And I'm going to get a crazy decimal. Okay. Now when we did this with the exact value, we got 6 square root 6. So let's check that they're equivalent. I'm going to do 6 times the square root of 6. And I get the same decimal. So that's a nice check as well. Okay. Staying in your Inspire, the only other part of this document is very much like your law of cosines in that I have a triangle for you, I've set up the proportions, I've made all the measurements, and I just want you to notice that it doesn't matter what the size of my triangle is. Again, right now, all of my ratios are 58. And as I change, they're going to change slightly as well. Now the question I have for you at the bottom is, why are there sometimes slightly different answers? Like there, my A ratio is 59, but my B's and C's are 58. Why do you think that that's happening? And it bugs people when that happens. And I want you to think about why. Do the same thing here. So as your angles and side lengths are changing, your ratios are staying constant. For the most part, there are slight differences, and I want you to think about why. There you go. And that's the end of your Inspire document. If you're just a must-do person, you're done with your video now.